Assalamu alaikum and good day to each and everyone. So this is our sixth lecture for this subject, the ES17. Okay, but first things first, before I formally start this discussion, I want again and again to verify or to highlight this point of information that you better downloaded the file that I have posted. I mean this file that I have uploaded in our Edmodo classroom, or I also highly encourage that you better print the file or this file for you to easily cope up or for you to easily follow while I am discussing this lecture, because that will serve as your outline for this video discussion. Okay? But nga, sa discussion na ito, sa video discussion na ito, ang pag-uusapan natin is about the relative equilibrium of liquids. So, of course, we will be talking about liquids because this is ES17 or fluid mechanics. So, in fluid mechanics, in this discussion, in relative equilibrium of liquids, ang pag-usapan natin dito is about the behavior of a certain vessel moving in a rectilinear motion. Way back, last discussion, I think, or last discussion, we have talked about the rotating vessel. Okay, rotating vessel. So in this discussion, we will be tackling or we will be talking about the moving vessel in rectilinear motion. Meaning to say, it's moving in a rectilinear motion. Gumagalaw yung vessel na ito in rectilinear motion. For example, yung mga truck carrying a water. Okay? So that is an example of a moving vessel in a rectilinear motion. Pero take note, sa rectilinear motion or sa rectilinear translation, there are three motions that we will be considering. These are the horizontal motion. Next would be the inclined motion and the vertical motion. Okay? So, let's start with horizontal motion first. Consider a mass of fluid moving a linear acceleration, A, as shown in figure 1. Considering a particle in the surface, the forces acting are the weight. Okay? Class, sa isang moving vessel in a horizontal motion, take note that yung forces acting on that body is the weight, this one. Weight is equal to mass times gravity, and the fictitious force. Yung fictitious force is this one, the class, yung fictitious force na ibig sabihin dito is yung reverse effective force, which is the ref. Then that is equal to mass times the acceleration. And the reaction N, which must be in normal force to the source. Take note, itong normal force must always be perpendicular to the surface acting or where the body is acting. So, yun, all in all, if we are to consider a body moving in a horizontal motion, the forces must be acting is the weight, which is equal to mass times gravity. There is reversed effective force, which is equal to mass times acceleration, tapos yung normal force, which is perpendicular to the surface where the body is acting on the surface. So that is all for the analysis for this horizontal motion. Next, let's proceed, or before we proceed to the inclined motion, let's first see the formula involving in a horizontal motion. A moving vessel moving in a horizontal motion. So we have this one. Let's first consider the derivation of the formula. As you can see in this figure, this right triangle, we have this angle theta, and kung kukunin natin yung trigonometric function in terms of tangent, tangent theta is equal to ref over weight. Okay? TOA. Opposite over adjacent. So, opposite is equal to ref or the reversed effective force. Then, yung adjacent ng theta is the weight. And obviously, yung ref is equal to mass times acceleration. Tapos, yung weight is equal to mass times gravity. Then, you just have to simply cancel out the mass. And then, all is, yung natira lang is tangent theta is equal to acceleration times the gravity. So, in this formula, tangent theta is equal to acceleration times gravity. Yan yung formula kapag yung analysis ng isang problem is about the horizontal motion which involves a moving vessel. Okay? Again, take note, tangent theta is equal to acceleration over the gravity. Therefore, The surface and all planes of equal hydrostatic pressure must be inclined at this angle theta with the horizontal. Take note, it doesn't mean na may theta dito is incline yung surface natin. Hindi. Ang incline lang dito is yung water surface at hindi yung surface ng inaapakan or pinatungan ng isang moving vessel. Okay? This surface is horizontal, pero yung theta is nandito sa water. Okay, gets? Kasi yun nga, obviously, ang topic na ito is about horizontal motion. So, horizontal motion, this one is horizontal, pero yung angle theta is nandito sa water surface. Because imagine, whenever a truck is moving, of course, may movement in water. And every time there comes the movement sa tubig, magkakaroon ito ng angle theta with respect to the horizontal line. Though horizontal yung surface ng for example, road, pero yung tubig natin is may angle theta because of the movement of the truck. So let us now proceed to inclined motion. Kanina, we have talked about horizontal motion. This time, we are considering a inclined motion. Meaning to say, yung surface na pinapatungan or inapakan ng isang vessel is inclined with respect to horizontal axis. See the difference? Dito, ito yung surface. Wala itong angle sa surface. Pero sa inclined motion, mayroon tayong angle alpha with respect to x-axis. So, yan yung inclined motion. Pero, sa inclined motion, obviously, may acceleration because it involves motion. Pero, take note, sa inclined motion, ang nadagdag lang is yung ref with respect to vertical axis, tapos yung ref with respect to horizontal axis. Kindly check this reversed effective force with respect to vertical axis. We have this mass times the acceleration at y, tapos yung ref at edge is equal to mass times the acceleration at horizontal. Pero yung weight as is pa rin, we have this mass times gravity. Then let's derive its formula. Tangent theta is equal to mass times acceleration, or let's say tangent theta is equal to the ref along horizontal axis over the weight, this one the weight, plus the ref along vertical axis. Pero yung ref, we have this mass times acceleration along x-axis over mass times gravity plus mass times acceleration along vertical axis. Pero as you can see, lahat na yung mass yung both numerator at saka denominator, meaning to say, we just have to simply cancel out mass. So, ang natira lang is yung acceleration along horizontal over the gravity plus the acceleration along the vertical axis. But take note, whenever you are analyzing a problem or whenever you are analyzing a moving vessel along an inclined motion, take note that the denominator is always positive or negative depending sa motion ng vessel natin. For example, yung motion natin or yung truck natin is pataas, yung gagamitin natin na sign is positive. Pero if it goes downward, meaning to say pababa yung truck natin, ang gagamitin natin na sign is negative. Okay, take note of that. Because we have these two signs for this formula. It's either positive or it's either plus or minus depending on the motion we are dealing with. So let's proceed to the vertical motion. We are done with horizontal, inclined. Now we are down with the vertical motion. Consider a mass of fluid accelerated upwards or downwards with an acceleration A is shown in figure 3. The forces acting at a point H below surface are the weight of the liquid. So, consider this tank or consider this vessel. Ang involved dito na forces ay yung weight above the point, this one. Tapos, the inertia force, which is the mass times acceleration, and the pressure force, which is the pressure times the area. So in this figure, in this derivation, ito yung formula na ito is not derived from this figure. We have this summation of forces along vertical is equal to 0. As you can see, wala tayong summation of forces along x kasi the motion or the movement of the tank is along vertical axis. So wala tayong summation of forces along the horizontal axis. So we have this force, force is equal to mass times acceleration plus the gamma times the volume. Tapos, with further derivation, we have this P, which is the pressure, equals to gamma H times 1 plus minus A over G. Again, as you can see, may plus minus dito. Take note, yung plus minus dyan, indicator yan ng, yan yung magiging indicator natin kapag yung tank or yung movement ng isang vessel is pataas or pababa. Gagamitin natin si plus kapag yung movement ng vessel natin is pataas. Pero gagamitin natin si minus, this one. Gagamitin natin si minus kapag yung movement ng vessel natin is pababa. Okay? So, that is all for the concept behind the rectilinear translation or rectilinear translation of a moving vessel. So in next video, we will be tackling about the examples provided for this type of problems. Okay? Wait class, before I end this video, take note that acceleration is positive for A is positive for acceleration and negative for deceleration. Meaning to say, positive yung acceleration natin kapag pabilis ng pabilis yung movement ng isang vessel. Pero negative siya kapag pabagal. Meaning to say, decelerating. Okay? So that is all for this video. We'll proceed for the examples of moving vessel.